Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on CanoScript. Alright, so yesterday I kind of had to stop in the middle. It was taking a bit longer than I thought. So we're working on implementing functions right now. So let's see. So, whoops, never mind. This is what I want it to look like. So we can do most of the, pretty much the listing and the parsing. We're having a problem with the generation. Because what would happen is, we basically get stuck in a loop, right? Because we call this and we repeatedly go through this. So what we need to do is generate all of the functions after everything else. Yo, what's up, Tim? How you doing? Like this. And that's not right. We need to do this basically. Like that. And then that is what we want, and we want to return it as well. Yeah, because we can call labels from any point in here because they're generated like it's two-pass compiler or assembly. So that is totally fine to do. So that's what we need to do. So let's see what we've got right now. So I think it's in the parsing where we're gonna want to do that. Do you see your oh, I did not see that. Yeah, I looked earlier because I knew you were working on that, but I didn't see it yet. Pull request. Yeah, but let's see, 1 hour ago. Okay. Let's see. Let's watch it. Ooh, okay, that looks pretty good actually. Okay, yeah, that looks really good. Let's see, how big is it? All right. Okay, 157. That's not too bad. Yeah. So I'll probably go through it later, right? After the stream. Let's see. Okay. Control O. Oh, okay. It was just it's actually good. All right. Control N. Open File Explorer. All right. All right. Files. Right. 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 Uh huh. Okay. Yeah. I see how this. I see how it works. I see that. Scan files recursively. All right. Free files. That's good. All right. So you call that. Right. All right. Yeah. So I'll go through it after the stream. Test it. Make sure it works, obviously, and then yeah, I'll probably merge it. It looked good though. Like you know, pretty simple, obviously, still, but that's really good. Yeah. Thank you for that. Yes. All right. Very cool. So let's see. Yeah. So I need two parts. So what I'm thinking is I'm going to change this up a bit. So I'm going to make a structure that I'm going to return from this. Um, hmm, let's see. So we're going to return from it both the functions as well as the regular nodes, right? So right now we're returning nodes, which is just a dynamic array of of a single node, right? Or of node. Well, okay, it's kind of yeah. Anyway, so we have that. We need to return nodes as well. So these are the nodes. So let's call it nodes still. And then we're also gonna return um nodes, which are the function, right? So this is sort of the first program, maybe even just the program, and that's what's going to be returned from here, program. So we'll initialize it. This program equals 0, and then okay, so that we don't have to change too much. We can actually just we can set at the end we'll initialize all the stuff and then return it like that. So we'll do no, program equals 0, and then program.nodes equals 3, and we'll return a program from there. And then we're also going to have the functions as well. So we're going to append it to that. And down here, it's going to be a program, and that's what we're going to pass in here instead of that. So it's going to take, we're going to have to move some stuff around, but I think that should pretty much work out. So what I want to do now is up here. So yeah, we need another one for the, so we have the loop and then nodes functions. Loop 0. And that's what we're going to append to when we capture a function. So where is the function at actually? Function declaration. So yeah, the declarations of the functions are going to be here. So in here, we're going to call VA append, but on that. VA append to, not to token, but to functions, and we're going to append a node. And then we'll just break here. I think we can break, right? If I am not mistaken. Or maybe a continue. Let's see, what's at the end of... Well, so that's going to break out of that. And then, yes, that should work fine. So a break should be fine, because that'll break out of the switch statement, essentially. So it should be good there. Right. Okay. Also, I'm going to refactor this because I don't like this. I'm going to pass this as a pointer, so I'll update that after I get this word. So let's make it compilable. Func.body. Ooh, okay. So let me think. How do I want to handle that? We can just take the. This isn't going to allow for subfunctions, but I'm just going to take the nodes out of there. For now, then we can refactor it later. 981. Right, return root. Oh yes, we want to return the. We don't have the program, but we can do this, right? Program. Dot nodes equals root, like that. Generate program. Okay, yeah. So now we need to update that. So let's go to generate. So this is going to take a program instead of a program. Okay. Then we're going to have to refactor stuff where we say nodes. So nodes. It's going to be a program. And let's say as a pointer action. Like that would be better. You stream daily. I try to stream pretty much every day. I do miss some days, but like usually at least 5 days a week. But you know, I can't really have a set schedule right now. But usually I stream at around, well, my time, right? So it's 3:30 now, so Eastern Standard Time. Around, 2 to 3 I stream usually on days that I am going to stream. Which I realize that is pretty late for you, but that's not right. 10. Nodes data. Let's see. Alright, now it compiles actually. So we still don't handle the function, but now we should be function foo right before assignment. Okay. That's your problem. Yeah, time zones make it hard, Alright. Yes, the function is ready. So when we encounter a function, we actually want to look in the functions rather than in the nodes. So that's why we get this error, actually. So, function call, yeah. So, get func. So yeah, the get func, it's going to look in the function. So we need to pass the state and the... So we appended it to there. So, right. We have to pass the functions here. So the program. Let's look at that. So get func, it's going to iterate over program functions.count. Yeah, so pretty much that's what we're doing. So we're going to remove it from the state, I suppose, because they're all defined in the parser, so we don't need to actually generate them in there, right? Nodes. Yeah, it needs to be a one of those, so like that. Okay, this is... Wait, hang on. Yeah, no, we passed the functions themselves, so we can just do this. Okay. Functions. Okay. Alright, wait, it's returning that. So... so the functions are those. Oh, shoot. Yeah, it's expecting it to return a function, not the nodes themselves. Wait, can I, so the function is that when we look at, let me turn a node from here. How much do we have to change for that to work? Function from that. Because we still have all the information stored in the function, so, you know, it's not, like, a big deal. It's stored in a node, rather. Function, so it's going to be a node instead. Okay. So we get a lot of stuff here. And we get a print error as well, because the function is not like this. It is a function value. That thing, I think, is what it is. Oh, no, it's a function that. So maybe we should even handle this differently, where instead of it being a list of nodes, it could be the functions. Well, but we have, okay, I don't know, we'll see. Node has no number of args, yeah, so we need to change that. So function function means parameter name. Why is that unused? Oh, okay, because it is, that's not right. Okay. Function, yeah, no, that. That's not even right. So it's not value dot that. And then it compiles. Yeah, it's still going to do a little bit more, but let's see what we get here. So function foo is still referenced before assignment. Okay, that's interesting. It shouldn't be. Let me try to print out all of the things here, right? So let's just iterate after we parse it. I is less than program.count plus whoops, I plus plus like that. Then we'll print the we'll just print the type of it. So type. It's like this. Program.data I. Program, so we have two. We have program dot, so we have the nodes. It's dot data I dot type, and then we also have to do another one for the function. Okay. Alright, that's fine. It doesn't have to look good. And we'll just replace this with functions. And let's see. So that node types with an S. Okay, and let's see what we get. We don't have any function, so that did not work. So the append in the parse did not work for whatever reason. Because we don't set them. That is why. At the end, we have to set the program.functions equals function. And then we can run it. And okay, so let's take a look at it. So we don't actually compile the functions. That thing. We recognize that they exist, but we don't compile them. So we need to call that afterwards. But let's see what we have here. Okay, so we have the call, but we don't actually have the declaration of foo, right? So we want it to go afterward. So after all of this, we want to call it on that. So let's do this. I'll probably make that into a function because I do use that quite often, printing the nodes, but later. So after all of this, we want to just basically want to print the like gen functions, right? So maybe we'll make that gen functions. And we're gonna pass the functions to it. So the program, and then we'll pass the state as well. And what else would we need, right? Like, we don't need any of the nodes, I don't think, and I don't think we need the file name. So we should be good to just pass the state in the program, or the state in the functions, and then we'll just basically we'll do this on them. Yeah. So maybe we could even just reuse this because it's gonna be the same thing, right? But I don't want to do all that stuff. So let's actually maybe move this into a separate thing, right? So this is sort of this is the grid of generate, and then this is generate like gen what? Gen program, right? Well, we'll call it that. Pass the state and the program nodes. It's going to do all this, iterate over it in the same way. So I will just grab all of this. Let's see quite a bit here. And I'll just put it into this function. So this, what do I call it? Yeah, gen program. Gen program. Oh shoot. I pasted it too many times. And let's see, did it paste it more than once? It did indeed. Okay, so let me delete this extra one. That's my bad. Okay. Alright. Gen program. So we need to take the program state, and the nodes. It's like that. Program. Yeah, so then we can get rid of this thing. So it's just nodes.count. Then nodes.dataI. And I think that's pretty much all that we have to do. So if we get rid of this one. Actually, here, I think we can do this. No, that's not gonna work. Yeah, okay. Just a bit limited, the visual mode in Kano currently. But that's something I want. So I want to be able to press the percent sign and then jump from one opening bracket or whatever it's called to another. You know, that would be nice to have. Also, that's a little slow. I'm not sure why. Like the deleting selections. But anyway, so we want to call that, and then we're going to call gen program on the function, right? After all. So, file undeclared. Alright, so we need to pass the file to them. That actually makes quite a bit of sense. Let's pass it afterwards. File. It's going to be, yeah, just the same file. So let's go gen program. Whoops. File. Okay. Program undeclared, yeah. 5G. So it is not program, it is. Yeah, we just want to pass the nodes. If we encounter a, well, no, shoot. That's not gonna work. So what we want to do, we're gonna have to pass the program as well because we need to search the function for this. Let's pass the whole function today. It's not that hard to do. Nodes and functions, right? Which are also nodes. Okay. Gen program. That's not super clean though, so I would like to do something about that. Okay. Yeah, and this we have to pass the same thing twice, so that's not a deal, but okay. And we need a comma here. Okay, so it compiles now. Let's see. So it tried to generate it, but it didn't actually generate anything. So that's interesting. Why is that? Oh shoot, because it generated just that part, but then we need to actually generate the body. That is the issue. Okay. So the body is a list of nodes as well, right? If I call this, and then call it on the body, it's the same thing, right? Oh, shoot, we don't have the body. So, wait, what are in the functions, right? How do we look at them? So it is nodes, and they are funcall. Yeah, so we need to do that. Functions, oh, but it's each one. So it's like a list of them. So how does that work? Hang on. Let me print them out again. So print out all of those. For size I equals 0, while I is less than a program. Functions. Let's print the type, right? Of node types. Program.functions.data I. Just print them all out. So is there only one? Whoops. Function deck. Okay. So we only append that one. That is an issue. Yeah. So I need to actually change how that's handled, right? So instead of that, yeah, that is a problem, right? Because we do this. Oh, but we have the func deck has a body of that. Okay. Right. So what we want to do actually is I call that, and when we encounter a function declaration, okay, function deck, we can call it again on the body, right? Gen what do I call it? Gen node or gen token, that's right. State node value on deck on body, and then nodes. And what is the in the body? Funky deck, that's what I meant. Yeah, then it generates the actual body. A lot in there though. Okay. I don't know. Let's see what it looks like. Index out of range. Okay, that's interesting. So why is that in range? Probably in swap 4 is out of range. What do we have in the function? Ooh, it's probably the return y, right? Get rid of this. Just have that, right? Oh yeah, because no, get rid of this. So you did actually catch that. That's good. Doesn't work. Fine. Next out of range. Okay. Looks good. Whoops, that's not right. So is this still out of range? Is it there? Okay. I don't have a debugger for this, so I can't really debug. It looks like that's probably where it is though. So that is 6 on the top there. And here, if I do print it, will not print, right? It's a good out of range. Yes. Okay. So that's where it's at. It's the in swap. And what is this for? That is setting it up for the return. Right. Okay. So what do I make this do? Then it actually, okay, it does do that. Next is with 6. So it actually, okay, it modified the x variable. So that is not something that we want to do. So the way that we're handling the scope is not quite right. But this works, right? Theoretically will work. Yeah, so what? In this way, we'll never accidentally call the function, because all the functions get generated below. So that's, that's good at least. Is this actually an issue? Well, no, because we pushed to it there as well. So what do we need to do to get this to work? So yeah, swap 3 is not right. What is it trying to do? It's trying to return y. The variable y is declared. All right, let's see. So when we call this, we push 15. All right, this is the x declaration, right? Let me keep part of the stack. So we have 5 on the stack. That is x, the variable x. And we push 15. That is the variable y in the function. Then when we actually get to the function, which is here, we reassign the variable. So we indupe 1. So that is the variable. We push 1 and we add. So we make it 16, right? Because it starts out as 15. We change to 16, and then we swap them. So why does the index swap with 2? 0, 1, 2. So it swaps with the wrong one. That is a problem. So it's trying to swap with this one. Okay. It's like 1 greater than it's supposed to be. And that causes the other one to be wrong as well. So it's something to do with how we're handling it there, and it's probably because we call it after this, right? Does that matter though? It shouldn't matter. Unless we're encountering the end. Let me look at that again. Okay, the only end is here. where we're popping off the only variable that we have for the function, right? And we return as well. So, that's not what it is. Okay, so it has to do with the variable. So when you encounter a variable, right? Variable int swap. So stack size minus index. And we get the variable location from there. Okay. Could it be an issue with that? Like accessing these global variables? Well, no, we're not even trying to access the global variable. So what is the issue with that? When we call it, we set it up. The function call is handled before. But then we create the variable, right? After the function call, we want to actually get rid of all of the variables, though. That's the thing. Wait, do we not create the variables? Gen function call. Let's actually look at that. Gen. Yeah, it does not. So, get the function. Generate the expression, but we don't set up the variables. Like they're on the stack. Hello, Stam. How you doing? It's a lot of emojis. So we don't create them. So where are they created? Are they created? Okay, when we start the function, they are. Okay, I see. A problem as well, though, is we don't really, like after this, we want to choose an int. So it's kind of hard. When you don't have a main function, it gets hard. Evolution project's been really good, yeah. How far along? Rust is perfect for it? Really? Is it ready to share or not yet? That's a bit. Right, but then we don't actually recover the stack after this, so that is a problem. Not really, there are no bugs. Okay. Well, yeah, whenever you're ready to share, I'd love to take a look at it. What is this? Iterated, so I'm just getting the top of it. Hang on, is that an issue? Is that what it is? Are we not supposed to do the -1? Oh, not right, but what do we generate? So we generate the expression. Okay, yeah, so that is not right. So we did want to do the -1. Why do we do the plus plus? Okay. Hang on. Let me look at this. So ignore this. Pretend that's not okay. And let me add a label for this thing. Yeah. File. Gotta go. Alright, see, I have it. Alright. So that is the label return. Then I'll be able to see sort of what's going on better. So what do we have? So we have return. So we undo. What do we undo? Oh, because that's the expression. So that is 1. So that's actually right. That's what we want here. Because that is the variable that we call from here. So I think that's okay. And this position is not right. We want to do plus plus after, right? So let me think why I would do it. Because I don't remember exactly. So the position, so we're trying to iterate the position. But we want to place it on the top before that. So actually, I don't think we want that. Okay, actually, excellent. It's hard to tell if it worked, though. Maybe I could add something. Maybe it's to make sure everything is working properly. So, let's see. When we do this, right, so we should have 16 on the top. So let's actually duplicate and print so that we don't get an underflow. And it is 6, so that is not right at all. So the problem is... Oh, shoot. No, because we're placing it there. Oh, yeah, but we're supposed to be placing it on the top. Hang on. Because we didn't pop yet, so we want to do it actually at the end. Because we pop it off, and then we want to do it. This is like the end of the scope, right? And that is 15. Okay, that is interesting. So why do we have 15? Why would there be 15? Because it should be getting replaced with the 2. So let me actually, let me step through it here. We have 5 and 15. So 15 is the Y, and this is the X, right? The global one. That's what we exit with, actually, at the end. Actually, it's interesting. Alright, well, anyway, so we have that. And then we call foo here. So this is what the stack looks like. So we indupe 1. It's actually the 5, so that's already not right. Because indupe 0 would be the 15, the one that's right at the top. So that is not right at all. So all the variables are like off by 1. I think that has to do with how we're handling the scope, right? Well, hang on. So, let me look. So in the type n, we all right. Shoot. All right. It's really hard when you don't have a main function, right? Because it needs to all be in the right order, but it also can't be called. Like we don't want to call like because we automatically just execute with it. Like the labels don't actually affect the execution, so we can't just place them in the middle. So what can we do? And the variables, they're not all in the right place when we call it. All right. Let's see. So pick this up here before we mess with the stack size and stuff. What does that look like? It doesn't look any different to me. So why does it think it's there? I don't get that exact. So let's go to var reassign, because that's what we're looking at. So we do stack size minus index. And the index is variable location. Which we actually generate here. But that should still be okay at this point. So why is it not? Let me write the index here. It is zoo, okay. And index. And also, I'm gonna print the state stack size. Like that would be useful. Stack size. Alright, let's see what all those output, right? What? Oh, it's just an okay. And let's see. Alright, stack size is 4. And the index is 2. So let's see, why is stack size 4? In here. Right here it is 4. Why is that? What are we doing that makes it 4? Because we go through this too. Viewpoint. Negative 60. Okay, but if we actually move this again, let's move this so it is down here, then the stack size will be different. Well, no, it won't be any different. Well, yeah, it's not any different. Okay, hang on. So I have a. So why is it 4? We have 5 and 15. That makes sense. And we call this. That doesn't push anything on the stack. And then call indupe. Go back to this function, not function, but variable reassign. But we generate the expression, so that pushes it up by 1. Right, so we have 1 there. We want to do the index walk though. or anything like that. So it should only be 3 though. So why is it 4? What makes it 4? Well, hang on. 4. Yeah, why? Why? And then, so we do that, and then we end up with move 1. It's supposed to be move 0, because we're trying to grab this value, which is on the top of the stack. Scoop and fit. Yeah, so we're grabbing the 5, and it should be 15. Right, so if this was 0, let's see, I just remove 1 from all of these. And is that right? So add, and index swap 2. So that should be 1 as well. And let me see. So and let's see what this is. So that should be 16. And it is 16. Alright. So it looks like we're just off by 1. Every single one for some reason. So at some point, we just add 1. Did you count that push 0? Let me see. So push 0. Where is that? Yeah, but that's not called yet, because we're at this point, right? We're here, right? So we're calling that. So it's like calling the function, and we jump here. So we don't. And then all of this anyway, like the push 1, or we undo 1. So that puts an extra 1 on the stack, but then this consumes it, right? This is an exit syscall, so it subtracts it in. So that doesn't even, like, even if this stuff counted, then it still gets consumed anyway, right? If that makes any sense. Like, that's not part of it, you know? And these are the only 2 that are relevant right now. So at some point, it just increments by 1, and I need to figure out why. It's just off by 1. So let me see. But we are, I guess it does actually use those, because we do this, right? We do it after. So I need to think. Let's see. Where's the native exit? That's at the top, right? Native exit. We do decrement it. But yeah, you can see this is what happens, right? So we generate the expression. So that pushes the 0. That's where the 0 gets pushed. And then this actually consumes it. So the stack position, I think, is actually right. The problem though is the stack size is off. So maybe I should print the stack size in every iteration of this, if that makes any sense. Print that. Stack size is that. That would actually probably be very useful. So let me go down here and remove this this one that I put here. We can see sort of how it goes through each instruction. Alright, stack size 0, 1, 2, 2. Alright, and let's see. So what are the instructions going to be? I'll look at so we have this instruction, right? This is a variable declaration. That's where it goes. Starts at 0, then it goes to 1 because this pushes 1 value onto the stack. Then it goes to 2. Let's see, but then we go to the call, right? So that's when it's 2. And then we exit. I feel like that's not right. Alright, maybe I should print out the type as well, so we can see. We can see what order it's executing in. Actually, that would be very useful. Type is that. Node dot type. Let's actually put that there. Node arrow type. And let's see. Forgot oh, there we go. Okay, that's actually good. So variable declaration, that is the x. Then we have the function call, that pushes 1. Yeah. Actually, maybe we should look at it at the end, because really it's 1 greater than that. Yeah, so what if we move this all the way to the end of the switch statement? Like this. Alright, that's perfect. So variable declaration, that pushes 1. And then function call, that pushes another 1, because that's the value. And then the native exit, that should push 1, but it doesn't. Oh, because it subtracts it then instantly. So that's all fine. That's 2 again. And then variable reassigns. This is in the function, right? It's in the function. Also missing. No, we're not missing one. Okay. In the function, we have variable reassign. And the stack size is 3. So the stack size is 3. No, but it's supposed to be... Wait. Then return stack size is 4. Let me look at the function again. Or look at this again. Variable reassign it's 3. But then here, when return is 4. So that actually makes sense. No, because that it's supposed to be 3 when we return. So that does it's still 1 greater. So where does it become 1 greater than it's supposed to be? Let's see. The rest of it is right. Stack size is 1 because we have 1 on there. Then it's 2 because we have 2 values on there. We still have 2 values on there. Then we have a third value on the reassign. We shouldn't. Alright, actually, I think what I want to do is something else, right? So we have the function call. Then I want to... Let's actually get it. So 4 0 y is less than the value dot call dot orange dot count and just pop, right? Well, yeah, pop. So that's gonna reduce the stack size by that amount. And pop actually. Stick and pop. We'll do that, and then we'll increase the stack size by the arg amount when we get here, right? So state stack size that's equals function dot args dot count. Okay, like that. Yeah. Go back and run it. Let's go here, and it's more wrong actually. Yeah, so now we'll go out of bounds again. That's not right. But what I'm thinking here is we do this. Is that right? Right, so we want to, we don't want to do that. No, that's not right. Yeah. Might be right. Well, hang on. So, because we want to pop it on afterward, we do that in here as well. So we really just want to reduce the stack size by that amount. So it's equals 3 stack size. And let's do stack size equals state stack size. I'm trying some things out here. Let's see. Here, yeah, because this increases the stack size by whatever the R's count is, essentially, and it pushes it on. I don't know. Well, hang on. I had an idea. Okay. I might want to change how I'm handling this. Now that I'm thinking about it. We can just jump past the function. Why didn't I think of that before? Like how we do with like if statements and stuff. We just always jump past it. Because then we wouldn't continuously call it. Hang on. That makes a lot of sense. Wait. And let me see. So like, oh shoot. Let me see. Let me generate how it was before. So in here, when we encounter the encounter this, instead of appending to the functions, we want to just not do that. We're going to append regularly. We're not going to have the functions anymore. So I'm going to have to get rid of those. Yeah, I'm just, let's see. We can leave them. I think it will still compile. But if we print them all out, function food. Yeah, so we don't have it in the functions anymore, so we have to look in the state functions, because those still are generated. I didn't get rid of it yet. So let's do type dash. Actually, it's here. So what is it? It's get func. And we want whoops, state function. And this is going to take functions, and it's going to return a function. Okay, so build that, and that still compiles. Then it shouldn't say looking for assignment. It still does say that. Okay. Oh shoot, because we don't push it. So type dash. Hang on. I just gotta get it compiling so then I can mess around with it. So what is this? Oh yeah, for each argument, and then we want to append to the functions. So, functions. Not the variable, but the function. Function is a pointer. Alright, let's see. 1026. Doesn't have to be a pointer. Yeah, so this needs to be a function dot name. Okay. And no, okay. Yeah, that is 54 here. It's a function again. That's gonna change these again, so we have to fix up that. Whoops, that's not it. No, wait. Yeah, that. Yeah, so it's right here actually. In the wrong ones. Hang on. Function name, that's what we're there. Then yes, function.args.count, that's what it is. Well, function arrow arg. Oops. Okay. I'm just trying to bring that function. Okay, no. Alright, so let's look at this. So now we generate here, but we only push 15, so we don't generate the whole thing. Because we don't generate the body current. So we hang on. Why do we get rid of this stuff? Now we don't set up the oh shit, I got rid of one of the things I don't want to. Yeah. Get rid of that. Okay. Yes, we don't generate the body of the function. That is obviously not good. Because of how we handle it in the parts, right? So let's see. In the function, what do we do? Right, we don't actually have to do this. Alright, let's see. We don't do that. Durations was no. We already do that. Right, we don't want to do any of that stuff. We do want to do that. Okay, Kano got. Oh shit, that was an error. Box type is 0. Okay, append. Let me see. So, and we have this, the variable we assign. So we generate all the stuff. So what I'm thinking is we do a jump. Where is the jump? Go though. So I want to call this because here we push, yeah, we're pushing it and it's generated just right in the middle. So it's gonna go through all of this. So at the start of a function, you want to just jump to label 0, right? Jump to the corresponding label that is generated at the end. Okay. Can we do that? And then we'll jump down here, call foo, and then we return. So like we won't continuously call it, you know? We won't try to return or anything like that. So like if we do this, does that work? No. Okay, why does it not? Index out of range. Is it the indupe again not working? Well, hang on. So that looks like the right number. Let's see. Let's like step through it. So we push 5, right? And then we jump to label 0. So let's see. We have 5. And this, the jump doesn't consume anything. We have the 5 on the stack. Label 0. And we push 15. So we're setting it up, right? And then we call foo. So we're in here. Indupe 1. So it's still wrong. Why? It's still off by 1. How does that happen? Why is it off by 1? Let me get rid of this thing. Let's see. So we have all of this stuff in here. Why does it do that? Hey, Alamaz, how you doing? How you doing? Why is it 1? I don't get why it's grabbing 1. Why does that happen? Why does it happen? So when we go to the variable, right? Generate the expression. No, not variable. The function. That's what I meant. Oh, should we append this function twice? We don't really want to do that. So we append to the block stack and the scope stack. And is the arg count off? Is our function dot arg dot arg count is 1, so that is right. So this goes through 1 iteration. Wait, hang on. Can we iterate the stack size there? Ooh, we don't want to do that. Because, wait, do we want to do that? I don't think we do. It's, no, it's not right. So that's not where it is. Hang on. So I want to do that because I want to assume it's there, but this is where we append it. Then it's the right number. So we don't want to iterate the stack size. Is that what it is? Because it gets iterated when we generate the expression, right? Okay, because if we indupe 0, then that's already right. So I mean, we're 5 and 15 from here. Indupe 0, so that's 15. We push 1, and we add to it, so it becomes 16. Then we inswap with 1, so that makes 16 and 15, and we pop it off. So that is how we want. So we reassign the variable. And then we return. So we indupe 16. And we inswap with 1, so that is there. So that's like right there. And we then end up, and return. So we don't pop it out. So we have 2 16s. So that's not exactly right. But other than that, it's like really close. Let's go to 0. So if we get that jump though. Yeah. we want to be able to pop it off. Well, do we have to? Well, yeah. So we want to pop it off at the end. It doesn't do that, right? So let's see. Why is it not? So if we go to the end, and let's see, end func. We want to scope end. Scope end. That does what? Do we append to the scope stack, actually? Okay, we do do append to it. But it's not the right number because we don't have the stuff after it, right? That we need to take into account. So really you want to append to the scope stack on the function call. We can't really do that. Okay, it's kind of complicated. So it probably breaks when we change the arc, right? So if we have a z in here. Yeah, we need to actually append is. For now, you're making the well. So I've made the Lexer, for part of it, right? But I need to keep extending it as I add more features. But it's just like compiling it, because there's the Lexer and the parser, which the parser are really kind of two separate things. But the parser and then the generator, where it actually generates the code, and I have all of them for at least part of it, part of the scope, right? Yeah. Okay. So we push 15 in that. We reassign the y, which is on the top. We don't pop. We don't pop them all up. So, well, Henry, if we do that at the end of the call, like after the call, then we'll be fine, right? Because that will clear it all up, right? I think that makes sense. Right, that's what I'm thinking. So, if we do that, and then we do basically the opposite of this, where we pop each one off. You know what I'm saying? Because that's what's going to be, well, no, we can't quite pop it, because if we return something, then it's not going to quite work. But we want to... Okay. Yeah, because right now the stack is kind of messed up, because we push these, but they never get actually popped off. They're supposed to at the end, but the stack size is off. System D. It does look like System D. I didn't actually, never thought of that. It's kind of fun. Alright, wait, hang on. So why is it like this? If I get rid of this, what does it look like? Let's actually, dot, and let's put the X back here. Let's just exit with that, right? Let's look at this. So we do 0. Alright, that's still right, you know? And the stack size here is 0, so we want to, we'd want to pop 2 elements off the stack. Swap with that. This swap is supposed to be with. No, that's right. Well, hang on. Swap with statement stack size minus position. Yeah, so that's still right. And we need to iterate the stack size for each one, but and then when we call the function, oh shoot, we can set the stack size when we call. That's not really something we can do because we generated it before, so that's not going to even. I don't know. I'm thinking. So we set the stack size here, and we need to iterate it. But it also breaks when we. Why is it break? I don't get that. So if we do stack size plus for each variable, then it's wrong. Right. Like when we're looking here, in dupe 1, then it's not right. It's supposed to be 0. Let's see. Mars Ninja codes followed. Thank you. Appreciate that. Okay. Why is it wrong? That's gonna underflow it next. I'm pretty sure. Maybe not. Run Vim with sudo and type. Yeah, that is a pro tip. It's a great idea. Genius idea. You should do it all the time. Yes. Yes, indeed. Do that, you'll know how to actually use Vim properly. You'll be a Vim expert. Negative 1,000 hours of work. Uh, hmm. Is it still up when I do that? Pen to the scope stack. Hang on. So I want to think. So when we pen each one, creating a new variable. Let's see. Yeah, we should only be able to reference variables, right? That are like global variables that are defined before. So like x like if it was defined before that, then we could access it here. But if it was defined down here, then we could not, right? That is the idea. So anything defined in here, we should only be able to access that. Which that makes sense. Like that would work with the regular scope. But for whatever reason, if we try to iterate the stack size, it doesn't work. So we try to, let's see, so when we encounter this is the first thing that we're going to encounter. Stack size is going to be 0. So we push that. And then it should be 0, right? Stack size. Let me print the stack size. Right here. Stack size. Okay, no. So, alright, our count. Yeah, so the stack size is 0 at the start. Yes, that is correct. Then we iterate it by 1 for the 1 argument. So then the stack size would be 1. The variable location would be, do I want to iterate this? I want to iterate it before. Is that be what it is? Ooh, yeah, because we want to set it to the stack size after it's pushed. I didn't think about that because when we normally do it, we generate the expression and it already changed the stack size. But with this, we aren't generating the expression. We're just declaring the variable essentially, right? So I'm looking at that now. Now it's right. Now it's right. Like we still have to generate this jump if we don't do variable 0. But if we did that, then I think this should work. We pop it off at the end. There should be 2 pops though. Why? Oh no, because we return. That's why there's only 1, because we're returning the other right. Oh, okay. Well, hang on. Maybe not. Hang on, let me go through this. So we have 15 and 15 on the stack, right? 15 and 15. And then we induce 0. So that's 15. Push 1. Then it becomes 16, right? Because we added. And we swap here. So that's 16 and 15. We pop this one off. So we have 16 and 15 on the stack. Then we return, we induce this one, because that's what we're returning. This is the line that we're returning. We swap with 3. So 0, 1, 2. Oh, shoot, that's going to be out of bounds. Shoot. So the in swap is generated wrong. Like, we want to put it here. So we might need to change that value. Like, ideally, it would get put there, you know? Then it would look like this. But then we want to pop these 2 off. It only pops 1 off. So there's 2 issues here. Yeah, so it's not going to quite work. Yeah, next out of range. That is what I thought. So why does that happen? So the stack size is 0 here. And that's what we push on. And then we encounter the end. Where's the end? And we do this. So we pop it off and we scope in. Alright, well, let's look at the return. So we do state stack size minus position. And the position is iterated. Right, but this is what's on the top of the scope stack. Right, so we would change it so it'd be 0, because that's what we push, and then we make it into 1, right? We print that pose is, maybe I should even use a divider for this, and then I can flip the dividers, maybe a bit easier. But for now, I'm gonna try this. So, pose is 0. Why is it 0? Wait, what? After we iterate it? Oh, shoot. Wait. You want to do that. Yeah. That's the position that we're moving to. So then, now we don't print out pose. Alright, but yeah, it's gonna be 1. So then, nope, that's not. In spot 2 is right now. So I think we're gonna get next anyway, but we still don't pop out the second button. Let me get a stack underflow, really. Alright, where would that occur? Well, let's step through it again. So we have 15, 15. And we do all this, and it becomes 16 here, right? Then we indupe 16, and swap with 2. So 0, 1, 2. So it becomes 16. It becomes 15. And we pop that on. Oops. So we have 16 and 16. We only want 1 16 on the stack, so that's not right. But then we return here, we exit, so we push it. So why does it stack underflow? Return here. Oh shoot, is it because I didn't end the jump? Yeah, okay, that's why. Okay. So we did extra that. So we have that extra value on the stack. We need to pop off. So in kind of the end, what does it look like? Actually, do we not want to increment this? Because we only go up to that value. So that could even be it. So then, no, we still only have 1 pop. So that's still not right. Alright, how do we handle it on the end, right? With type end. So, scope end, that's what it is. Let's go there, and scope stack that. So we get the top of the scope stack. Well, it's greater than that. We put generate pop. Okay, and then we also remove the variables from it, that's on. So gen pop state stack size is greater than the top of the stack. So we don't remove it from the top of the stack. Stop. No. Why examine this? Okay, there we go. I would expect 2 pops, but there's not. So I need to look at that. And no, I don't want to do that. I want to do it in the type way. Right here. Yeah. So we don't want a gen pop in there. We don't want a pop here. Right. Well, do we? You know what? Wait, we do want a pop. Well, hang on. Let me think. So the state stack here is going to be 0. We add 1 to it. And that's where we swap. So that actually gives us the right value, but it's 0 here. So while it's greater than 0, we pop. So why does it not do that? But then we push 1 more on here. Yeah, but we swapped it. So file state 5. Let's see. That gives us the 2 pops, but do we want to do that? Yeah, because we always want to pop off that extra one. So I counted that out, but I didn't want to do that. I think that's what the issue was. Okay, if I add this jump here, right, I jump to go to 0, and builder. And let's see. So we execute that. So when we try to generate that jump. So when we get to a function, we want to gen the label, right? So let's see. When we encounter a then, or when we encounter a wall, we generate a label. And a then we don't generate the label. Hang on. So an end we do generate the label. Gen label. Let's try this. Let's see. Try that. Before the function call, we want to generate a label. No, we want to generate a jump. Hit that way. This might break stuff because we haven't iterated it, so I need to look and hit that. Then label 0, and we have jump labels here, so it generates that. Alright, so let me modify this then. Do exit with. Actually, that's not really. Well, let's do this actually. Let's do x equals 12, and let's do x equals n plus 2 plus 1. Okay. We'll exit with x, and it should be 13, right? Some unclear label. Okay, the label got very messed up. Oh shoot, because we subtracted it from the thing. The jump label at the end. Why is that? Shoot, it generated in the wrong place. Hang on. Because we put in the function call. That's not where it's supposed to be. But also the jump label messes it up. Right. That's gonna break regardless. Yeah. Okay, so that's not right. Because we don't have a label value here. I forgot about that. Right. The end has a label value. We want to jump to that value, but how do we do that? So we generate the labels all in here. So maybe we need to do that in the parsing. I mean, kind of one of those, we need a label with it as well. So let me see. Where do we have the function type, right? Funcdec. Where's funcdec? Where is it? Did I go past it? I guess I did. So let's add a label here. And then in the parts, we can set that label in the same way that we do with like a then, right? So, let's see. Let's go to a then. Yeah, so we want to basically do this. These two things here. But with the function here. Like that. There's some like some messy stuff because I've been trying to figure out as I go. But let's see how that looks. That broke it. Why did that break it? Hang on. Let's see DVD. And let's just run. Let's see where it breaks. If that view compare really. So view compare broke. Why is that? What's the view compare that broke though? So let's see what do we have view compare. Get func, get variable location. Data. I feel like it's not that. Alright, so it's probably in get func. Oh shoot. Did I mess up the oh yeah, I know what happened. I know exactly what happened. I forgot to handle it right. So TT yeah, I forgot I was okay. Whoops, go down here one more. No, wait, what? Yeah. Right here. No, wait, dang, it's all the way down here. Right here. So I did it, I set the value dot label. I want to set the value dot func dot label. Because that was overwriting everything else and just saying it to 0. So that's why that. Yes, build that. Okay, let's look at dot chasm. And it's still the wrong label. Why is that? I'm using the wrong thing. Type that. Let's see. Yeah, I did the same thing. So value dot okay. Okay, I got it again. And now it looks like it's the right label. So our label. The next other range. Okay. What did I have? So let's go through. So we push 12, push 15, 15. Because we jump all the way to label 0. We have those. We do the index 0, so we change this and that becomes 16 and we swap it with 1. So 0, 1. So 16 and 15. No. This one. Well, okay. So that was wrong. That's wrong. We're swapping with the wrong one. Wait. Hang on. Let me start over. It's 12. Then 15 and 15. We can do 0. But, okay, yeah. I forgot to add that one. Push 1 and yeah, it becomes 16. And then we swap with this one. So this is 16. That's there. And we pop out this extra 15. So we have two things on the stack. Keep deleting too many. Okay. So these two. And then dupe 2. So 0. Okay, and that's wrong. So why is that? Why does it have the wrong stack size? Shoot. Because we deleted the wrong thing, yeah. Yeah. 15, 15. We do this one. And another 15, 16. No, we can swap. Yeah, I think I did it wrong again. 15. Get rid of this one. So we have that. Okay. Then that is right. Okay, and then we indupe 2. So that's 12. So we have 12 on the top. And push 1. And it's a 13. We can swap with 3. So 0, 1, 2, 3. So 13. And this one is 12. And we pot this off. We indupe 0. So 16. 0, 1, 2. So we place it here. And then we pop off this. And that. Okay. And then return. So now we end up right here. Call food. We try to indupe 3. Okay, so that's where it breaks. Because we set up the stack there on the function call. Right? The stack is not set up properly. Let's try that. Because we need to reduce the stack after that, but we need to actually push it on it, if that makes any sense. Then it works. Okay, then that actually works. So, does it work? So we don't have a way to. We can't use this in expressions. That'll probably be the next stream. But let's try to do an if statement here. So if y equals 15, then I don't know if we can have an early return. I'm not going to try that right. Then x equals x plus 5. Then we'll do else x equals x plus 1. And we return the y still, but it doesn't. It just sets up a stack. It doesn't actually set it. So that is something else. If we aren't setting it, we want to pop that off, but we'll worry about that later. Let's look at the compiles. You get 17. Okay, that is promising. 17, because that is what this would be. But if we change x, no, if we change y to 14, then it should be 13. Now we exit it, right? 13, there we go. Okay, so we can use if statements in there. I'm gonna get rid of this. And let's see, I want to fix these warnings. So gen program, use parameter function, if that's okay. We can get rid of that. Because that is not anymore at the moment. And yes, we don't want to pass it here. We actually want to get rid of it from the program entirely, but we'll do that. Parameter iterations and parts. Okay, that's fine. It's no. then unused parameter, unused variable start 865. Alright, get rid of all those things. And then it's not gonna have to rebuild it. Alright, let's look at what? Oh shoot, wait. Oh shoot, that's printing from other stuff. So let's see, I'm trying to go where I'm printing it out. It's not there. It's this one, yeah. So I'm gonna get rid of that. Okay. And do that. I'm gonna plug. Yeah. Alright, so it's just some debug stuff. Then Kano. That. Okay, and that works. So let's look at the assembly. So there's a bit of stuff here. So we have the variable declaration. So this is at the start. This is X. Maybe I could even include the variable name. That would be kind of cool. But yeah, so we declare the variable. And we jump to label 0 because we just want to skip past this function. Yeah. So I should try declaring more than one function. But anyway, so we skip past this function because we don't want to execute it. So just go right to label 0, which is, where is it? I guess this is a big function. Label 0 right here. And push these two values, and we call it. So we jump all the way up to here, and we go through everything here. So like we are doing this, which is the if statement, which we're comparing. We go through all this stuff, and basically we set all that stuff. And we can't use the return right now. So like we return, it sets up the stack, but we can't actually place the value to that. Not yet at least. Like I'm gonna work on that. It's not. I don't think it'd be too hard. But yeah. So we have that, and then we actually exit here, and it all seems to work. So that's pretty cool. Let me try more than one function. Let's just return. Whoops, return if it's. Okay. Let's look at that. So do we have main? Yeah. In the main, it's not actually an entry point. Using ggdb and ggdb2 flag. I actually don't know. I don't know. It's just sometimes I use one, sometimes I use the other. I don't. I'm not sure exactly. Let's see. Maybe this will give a good answer. Debugging information in the operating system's native format. Specifically intended for GDB. Extra one, including macro definitions. Oh, okay. Alright, so it's like using dash O, O1, O2, O3, that kind of thing. But for debug. So it just has extra stuff, I guess. I didn't actually know that, but I think that's what it does. Okay, let's see. So this, yeah, I'm not sure it's gonna work. So push 15 and swap 1. Right, so that's what we're returning. Yeah. Okay, and that should be fine actually. We pop all the stuff off. Why do we pop so many things? That's probably not good. And this is very much not good. So the stack size must be messed up. Because we popped too many off, I would suppose. So why is that? For the type. Yeah, so scoping, let's go to that. Yeah, saw GGDB2. Yeah. I don't know. Hey, for Kano, what am I using next? I don't know. Because for the debug one, because we have like make debug or whatever. Let's see. Yeah, so it's the same thing. I don't know. That's just what I kind of got used to, so that's why I put that. Okay. Scope stack. Yeah, so it gets it from the scope stack. Okay. Right, so that did not quite work. Actually, oh shoot. There could be an issue, right? The thing with that is... okay. And do that, so we're trying to get that variable. I think we did not push it properly or something. the scope stack. Is that what it is? This is an interesting issue. But yeah, so like, why do we pop off this manufacturer? So on the end, type in. We generate that. And the end func. But so why is that the top of the scope stack? It's so much less than this. Oh shoot, because we go through all this, right? And this pushes extra stuff, so that's why. Shoot. Okay. Right. You kind of need to evaluate the functions as their own thing. Right, so we probably should, okay. So it works without this extra function, but obviously we want to work with all of them. Let's start with the stack. I think I pretty much have to go though. So I'm gonna get this, right? So start of let's get one, but there's some stack size issues. So yeah, I'm gonna think on how to fix that. Right. So basically what I'm thinking is if we sort of evaluate them separately, but still at the same time, you know, so basically we have the body of the function, we evaluate it when we call it, but then the stack size just returns to what it was before, you know? It's like the stack cannot be influenced by that at all, except from like the return, right? Because that is what's causing our problems, I'm quite sure. So we're trying to pop it off, and then we're looking at the top of that, yeah. It's kind of hard to explain, but I'll go into it in the next stream. So that's what we're working on, getting the functions to properly work. Yeah, and I'll probably, in between the streams, I'm gonna go through and clean it up a bit, because it's kind of messy from all the different ways I was thinking about doing it. But yeah, I think I've got a good idea now. Should be able to get it working. Yeah, so later today, I will look at that pull request, by the way, on Kano. But yeah, so that is gonna be about it. So thank you guys for watching, and do you plan to make a debug? Yes, at least for this. I'm gonna make a debugger for, I'm not sure if this is what you mean, but for the bytecode here, these files, the TIM files. Yes, I do plan on doing that, because that would be actually really helpful. Yeah, if that's what you meant. Or if you meant just like general debugger, like GDB, then I'm not sure. That's what you meant. Okay, the GDB one? Or what? TIM files, yeah, okay, yeah. I do plan on doing that, and I don't think it'll be too hard to do, and it would be very helpful. So I do plan on doing that probably pretty soon, because there's like a lot of times. But yeah, so that is going to be the end of the stream. Oh, shoot, unfortunately. Yeah. Hello. Yeah, hilarious task. Yeah, pretty large. Yeah, so I do have to go. Sorry, Jin Bada. Oh, but yeah, that's the end. So I'll see you guys next time.